Hello everyone, welcome to Chemazon-Complete Chemistry. In our today's video, we are going to discuss the question 15 of the JAM 2022 paper. So the question is the reactivity of the enol derivatives towards benzaldehyde. So all these are what they are? These are the enolate ions. And what is the difference? If you see, only this oxygen metal bond is different. Okay, so we have to check this reactivity of these enolate ion with benzaldehyde. That is which reaction? This is Aldol condensation. Right? We have to check the reactivity with this. So how do we check the reactivity? We must know what the reactivity depends on. So the reactivity of the enolate or enol derivative, it is directly proportional to the electron density on the oxygen atom. Why? Because suppose if I write down in general, if I write down this is the enolate O and let's say this is the metal ion OET. This is going to react with the benzaldehyde. Benzaldehyde we know this is delta minus, that is it is more electronegative. So it will pull electron density towards itself. The carbon in carbon becomes electrophilic, and what happens? This bond breaks and then the electron density is transferred to this carbon atom, and this negative charge is going to then react with this carbon in carbon. So more is the electron density on this oxygen atom, more is going to be the electron density on this carbon, and hence more will be the reactivity of the enol with the benzaldehyde. Okay, so for understanding the reactivity, we have to see the bonding. Okay, there are three different types of bonds. One is oxygen lithium bond, another is oxygen silicon bond, and third one is oxygen zinc bond. Now, if we see oxygen silicon bond, this is going to be the most strongest bond because we know silicon has an empty d orbital. So the lone pair of oxygen can be easily donated to this empty d orbital of the silicon and show a pi back bonding. Okay, it can show pi back bonding, and hence since oxygen is donating its lone pair to silicon, the electron density on the oxygen will be minimum in case of oxygen silicon bond. Electron density will be minimum in case of oxygen silicon bond. So if you see all the options, in which option you can see the reactivity of silicon, that is 2. Compound 2 will be least reactive. So you can see it is only one option. So now we have to compare between 1 and 3. Why the reactivity of 1 is maximum. Now here if you see oxygen lithium bond, it does not exist as a bond like this. In fact, it will exist like O minus and Li plus. Now this is which type of interaction? Interaction between ions is called as an ionic bond. Right? So there exists an ionic bond between oxygen and lithium. So here if you see the oxygen will have the maximum electron density. Okay, because it is an ionic bond. Lithium, it is a very highly electropositive element, and oxygen, we know, it is one of the most electronegative atoms. Okay, so here the electron density on oxygen is maximum. So since the electron density on oxygen is maximum, the reactivity of oxygen lithium bond is going to be maximum, and oxygen zinc will be in between. So what is the correct answer? Correct answer will be the reactivity of 1 is maximum, then 3, and then 2. Okay, so what is the correct answer? We have already seen the correct answer is option D. Okay, I hope you have understood the solution. Thank you.